Welcome to analyzing quadratic functions for Pre-Calculus Math 11, and today we're taking a look at standard form quadratics, which is section 4.5 from our book. So a quadratic function with an equation of y equals ax squared plus bx plus c, and again remember that a, b, and c have to be real numbers, and a can't equal 0, is called the general form of the quadratic function. So it's very general because we don't really get too much information from a, b, and c. It's very difficult to graph the general form of a function. So we deal with this by changing from general form to this other form that we have, y equals a x minus p squared plus q, by completing the square. So we saw in the previous unit the process of completing the square. Now we have this y value sitting in there. That's not really going to change the process very much. And if we go from a general form to a standard form, we can graph this quite easily. So let's do this. We have y equals negative x squared plus 8x minus 19. We want to complete the square. So let's see here. Let's start with spreading it out a little bit. Negative x squared plus 8x minus 19. So just move a little space over. The first step was always factor out any coefficient on the x squared. In this case, we have to factor out a negative sign. This is where we take a look at the linear term, which is negative 8, half the linear term, which is negative 4, and squaring that is positive 16, and that's the amount that we add in and subtract off because we want to add in a net 0. So plus 16 minus 16, that's basically 0. And we have the minus 19. The next step was always to remove the negative constant, in this case the negative 16, by multiplying it by the coefficient, which is a negative sign, which will make it a positive 16. We complete the square, so x minus 4, it's always that linear term, perfectly squared, minus 3. So what we've done is we've gone from a general form equation, so this is general form, and by completing the square, we've gone to standard form. Certainly from standard form, we can pick off a few pieces of information. We know the vertex has to do with that p and q value. In this case, the vertex would be 4, negative 3. And the axis of symmetry, if we recall, is an equation of the form x equals. It's a vertical line, and it has to do with the location of the x-coordinate of the vertex. So we have an axis of symmetry of 4. Let's sketch this. Let me just write this down here so we can see it a little bit better. We have a vertex of 4, negative 3. 1, 2, 3, 4, negative 3. It is opening down. It's a standard parabola, a equals 1, so it's not expanded or compressed vertically, but it is opening down. So kind of that out 1, up 1, but in this case out 1, down 1. 2, 4 is down. 3, 9 won't exactly fit, so there's a parabola. It doesn't have any x-intercepts. The y-intercept we could find certainly. But there we go. So let's take a look at a second example. Determine the coordinates of the vertex of the graph. So if we start with y equals 9x squared minus 12x plus 8, why don't you hit pause here, see if you can complete the square on this one. This one's going to be a little bit more challenging. And see if you can determine the equation, or sorry, the coordinates of the vertex. So we're going to factor out a 9. This one's a little bit different. We're left with 12/9 x plus 8. So again, we're getting in a little bit of fraction work. I'm actually just going to rewrite it by reducing 12/9. Both are divisible by 3, so that's 4/3. So our linear term is negative 4/3. Half of that value, because the 4 in the numerator, we can divide that by 2, is negative 2/3. and the square of that is positive 4/9. So maybe take a second, go through that, make sure you understand why each of those terms are what they are. That 4/9 is basically what we're going to be adding in and subtracting off. So we have minus 4/3 x plus 4/9 minus 4/9 plus 8 hanging out at the end still. We need to factor out the negative constant, in this case the minus 4/9. Negative 4/9, let's just show you here. 9 times negative 4/9 is basically a positive, sorry, it's still negative, but it is a negative 4 plus 8. So a few more steps here. Negative 4/3 x plus 4/9, and negative 4 plus 8 is positive 4. And we get, by completing the square, x minus the linear term in this case, which is, or sorry, half linear term, which is 2/3 squared plus 4. So the vertex in this case is 2/3, 4. So still a fairly straightforward completing the square process, but because of the fractions, maybe a little bit more challenging. Finally, why don't you try this example 3 on your own? Graph 2x squared plus 12x plus 13 by completing the square, find the axis of symmetry, the vertex, and graph it. We have y equals 2x squared plus 12x plus 13. We're going to factor out the 2. So I'm going to motor through this a little bit. Hit pause if you need to at any time. The linear term is 6. At least the coefficient is. Half the linear term is 3. The square of that is 9. So we have 2x squared plus 6x. So we add 9, subtract 9, and we add 13. The negative 9 we need to move out of the bracket. We need to expand that away. 2 times negative 9 is negative 18 plus 13. So we have x squared plus 6x plus 9 minus 5 in this case. And by actually completing the square here, let me just shift it to the right a little bit. We get y equals 2. X plus 3 is the complete perfect square. And minus 5. So vertex, negative 3, comma, negative 5. Axis of symmetry is x equals negative 3. In this case, a is 2, and it opens up because it's really quite happy and it's smiling. So vertex of negative 3, negative 5. Nice dot there. Because the a value is 2, we go, instead of out 1, up 1, we go out 1, double that to 2. Instead of 2, 4, we go 2, 8. And again, right across the axis of symmetry, we can hit the other points fairly easily. And you know what, the 3, 9, which became 3, 18, that's going to be a little bit far off our graph. So let's just connect the dots, nice smooth curve. And we have a pretty good little parabola there with that axis of symmetry in there at negative 3. This ends the notes for standard form of quadratics, section 4.5.